Three things. First of all, I made this up, the 11 factors of a productive software organization. That is an intentional take on the 12-factor app, which maybe some of you have heard of. That was a guideline for how to design apps in a PaaS or serverless environment that Adam Wiggins from Heroku did. I'm an alumni of Heroku, so I feel like it's okay to kind of riff on that. Originally, I thought I had 12 factors, but, off by one errors, they happen. Little funny story. Adam basically made up those 12 factors the night before Heroku's first developer conference. They were based on a lot of great experience, but he basically just threw together a website, the 12-factor website, put them together. I basically did the same thing. When I was flying in yesterday, I collected my thoughts on what works and what doesn't as a software development org, and it turns out I had about the right number, and so now we've got the 11 factors of productivity. All right, we'll talk a little about why serverless in general, and spoiler alert, using serverless is the last factor of being productive, so that's how we tie the two together. And we'll also talk about what's new in App Engine. So why should you listen to me? Did I just make all this stuff up? Yes, I did, but there's some of the places I've worked over my career. The first two were not in cloud, but it was actually PayPal and Amazon was a super interesting dichotomy. I did an internship at PayPal, and PayPal was still in the monolith software app mode when I was there. Things were really, really slow to develop. It was very, very painful to get things done. It made being a product manager not very fun. It made me think I wanted to be a product marketing manager. And then I actually tried that, and that wasn't fun either. Turns out it just wasn't the right place to do it. Then I got to Amazon. I was actually working in the advertising team at Amazon. But Amazon, in sort of a lot of widely publicized papers and talks, had a few years earlier kind of gone through this transformation where they took this one big C app that was all of Amazon. I mean, this was circa, 2003 or 4 or 5. And they split it into hundreds of services. That was even before services were called microservices. And I got to experience that firsthand. I saw that actually it really did work and it really was beneficial. But I wanted to find sort of the Silicon Valley startup story. And it just so happened that I had a failed startup where I built a Ruby on Rails app and taught myself Ruby. And I was looking for a role, and literally on the Crunchbase One ads, saw a job for a PM at this company called Heroku. And I tried it out when I was doing that app. And I was one of the first dozen people there. I PM'd Heroku Postgres and the main Heroku product. And I got to see both internally, Heroku, sort of some of the things we did well on being really productive as an organization and things we did really, really not well. And I also got to see lots and lots of customer apps running on Heroku and see sort of those same, good and bad. After that, I was at Docker for a couple years. Again, sort of got to see both internally some good practices and bad practices, and also lots of customer good practices and bad practices. And then I kind of found Google Cloud and been enjoying that ever since. All right, so let's talk about the 11 or 12 factors of a productive software team. All right, number one, the YC motto, build something people want. It doesn't matter how productive you are, you can make things lightning fast. If you build things that are useless, that nobody wants, that don't have product market fit, that is the biggest productivity suck. Essentially, your productivity is zero if you build things that nobody actually uses. How do you do that? Well, it's actually not too hard. Talk to customers before you build things. There's a ton of documentation on this on the web. Talk to people. Emailing people doesn't count. You might email folks. It's not the same medium. It is amazingly low bandwidth versus actually talking to people. I actually like to think of it. If you've ever seen Gorillas in the Mist, Jane Goodall, she was in the jungle observing the chimpanzees, and that's what you want to do to figure out what you want. Whether you're an enterprise company or a consumer company, go to your target audience's sort of native habitat. Watch what they do. See the problems they encounter. Don't ask them about solutions. if you understand the problems really well, then you can make good solutions for them. And to me, that is the key to making things that people actually want. All right, so this was actually something that one of my colleagues at Amazon said. I thought it was the funniest thing ever. I added the parentheses here. Premature optimization is the root of all evil. This happens again and again and again in software orgs. You'll say, well, we can't do it this way because that won't scale. Well, who cares? Do the fast thing that doesn't scale. This way you can test out if what you're building is actually useful for people. Don't solve problems that you don't have yet, because that means if you don't have the problem yet, that means you don't understand the problem. You might think you're solving a scaling problem you're going to hit in 6 months, but odds are in 6 months, the actual scaling problems you'll hit will be completely different. Or if you were right, you'll understand it even better. And sort of a corollary to that, don't plan for scaling more than 10x past where you are, even if you're in hypergrowth mode. You might be hypergrowth, you're growing double-digit percentages every month in terms of the usage of your product, so presumably a software product. You might want to plan for 3 months down the line when you're 50% bigger, but don't plan for when you're 10x bigger, because it's really hard to imagine that. Just kind of keep doing those sort of 3-month, 6-month things. Another sort of great way to avoid premature optimization that I've seen work in various forms is sneakerware. You might have some really, really hard problem, and it's going to take a ton of time to solve it. But if you can solve it by just faking it, that works really well. Kind of a story there that illustrates that. When I first got to Heroku, we had this dedicated database product. There was a shared database product where you got one database on a big cluster, and we could spin those up programmatically in a couple seconds, and that's what most people used. But if you wanted to pay the massive amount of like $200 a month, you could get this dedicated database. You had a whole virtual machine to yourself. So it turns out if you went into the interface, you clicked it, you get a message that says your database will be available in 24 hours or less. What really happened was it emailed one of the engineers at Heroku, they went into the AWS console, they spun up a virtual machine, then they went in and manually configured your app to use it. That worked great for the first year there, when we had about a couple hundred of those dedicated databases. Pretty soon we were seeing that it wasn't scaling. That's when we fixed it. But if we had said, no, we need to scale, we need to plan for the future, the whole product would have been out 12 months later. And we wouldn't have learned a whole lot of other things that we learned. So don't prematurely optimize. All right, this is basically the opposite. This is how do you avoid premature optimization? It's so hard to do. Even if you're just like writing some code, you might be adding some extra tables to your database or some extra fields. Be like, well, I don't need this now, but I'm going to need it later. And it doesn't cost anything. Still costs mental bandwidth, still takes time, still has the opportunity to create bugs. So a really great way to avoid premature optimization is something called a spike. That's where you build something. You give yourself some really short amount of time, 1 week or 2 weeks, and you tell yourself or your team, we are not going to use any of the code that we write in this week. We are purely doing this just to test to make sure that we can build some software that actually works, that bears some resemblance to the app we ultimately want to make. What's great is, after you make a spike, you can try it out with customers, get their feedback. You also may encounter some of the hard technical challenges in actually building the thing. You might try to do something, make a dedicated database, and realize, oh man, that's really, really, really hard. And so it's a method of discovering what's hard and what's not, and testing to see if the thing you're going to build is actually useful. Often I've seen teams plan to do 2 or 3 spikes, basically a week or 2 each, and then go on and build the actual thing. Sometimes you'll discover that your spike is actually totally good enough to be the actual product. And isn't that awesome? You've got something in 2 weeks that you can then actually start deploying. All right. Another thing. I found that really productive organizations are generally shipping really good quality things. It feels great to ship something good. It feels really bad to ship something bad. And so it's really, really hard to do. I think we sort of have this prototype in software of Steve Jobs, who's like the quality tyrant. He was sort of famous for berating people about like, when the quality wasn't up to his standards, about how bad a job they were doing. So I think the trick here is you want to be ruthless about quality, but you never attack the person for something that's not high quality. You talk about the product that was created. You assume good intentions, and you don't make it personal, but you still have a really, really high quality bar. And I think ultimately everybody will feel really, really good about building good things. And that actually really helps quite a bit for having a productive org. All right, next. Start with a monolith. Microservices is all the rage these days. Everybody, you read a ton about it. You'll read blog posts about, my microservices architecture for building the next, dog food selling e-commerce site. I've seen actually at one of the places I was at, the team was building some web services. I'm not going to name names, and they were sort of living in the microservices world, so they decided to make it a microservices app from day one. It had like 5 or 6 different services. It was a total mess. Basically, this is really just a corollary to the premature optimization. What happened in that case was the team was solving problems that they didn't understand. They thought the microservices architecture would solve things really well. It actually made everything harder. So it's really simple. Start off with a single code base, and then as you discover what's wrong, you split it off. And I think that's actually the next slide. Yep. Okay, so if you do start with a monolith, does that mean you stay a monolith forever? No. That's what PayPal did. And eBay did. That's what slowed them down and like let Amazon overtake them 15 years ago. It's almost hard to remember, but like it's like back then, like Amazon and PayPal were kind of like neck and neck, or Amazon and eBay. So you don't stay a monolith forever. You split out services as you discover your scaling problems, and those scaling problems can be organizational or they can be technical. For example, one pattern I've seen over and over and over again is some software is getting some really, really good uptake, and it's starting to hit some performance problems. And when you look at it, it might be like the database that is causing the performance problems, but it's like one table is like 95% of all the databases load, or 98%. At Heroku, we had a group messaging app. It was basically their whole reason to etre was that you couldn't send group text messages on iPhones. It's kind of crazy to remember, right? So they had this group messaging app to solve that. Worked really, really well. They started as a monolith. They had a Postgres database, and there was a messages table that was like 98% of the load on their database. And they pretty quickly got to the point where they couldn't scale up a single database larger than what they had. They were using the very biggest database out there. There were a lot of other data stores besides Postgres that would have been great for them and that were great for them. So what they did, they split out a service. It was like a messages service that had it was backed by a database that was ideal for that workload. And boom, they solved the problem and they moved on. Another common sort of scaling thing is the team. I'm a believer in the 2 pizza rule. If you can't like feed your team on 2 pizzas, then it might be time to split it apart. Or the can everybody fit in the conference room thing. It's as whatever the end law is of like the number of connections in a team, it becomes really, really hard once you get past 12 or 15 people to be a cohesive team. So you split across. So maybe your scaling problem is organizational. You split out a separate team. And then they can sort of act as their own team. Works really well. That is, I'm going to skip to number 8 here because that's correlated to this. So when you do split out microservices and teams, then this is really, really important. You need to make them technically and organizationally independent. What do I mean by that? I mean, there is actually a team behind each service. The whole notion of like a microservice that kind of manages itself is, I think, a bit of a fallacy. It does happen, but the pattern I've seen over and over and over again is you have a microservice, it has its own team. Really simple. The teams can be as little as one person, although you hope they don't get hit by a bus, or they could be like a full 2-pizza team. But this works really, really well. That way that team can develop its own culture. They can have their own planning process. Maybe they decide to do a 2-week sprint instead of a 1-week sprint because that's what works best for their own code base. But they're their own separate team. From a technical perspective, independence means that the team can deploy their own code base independently. And this is like a really easy smell if you've done microservices wrong. If to deploy your service, another team needs to do a new deployment of their service, and so you need to do this weird coordinated thing between the two services, you did it wrong. You're not getting the benefits of a microservice. You just made it harder to deploy new software. So how do you do that? You have stable versioned APIs that the services use to talk to each other. Those APIs can be HTTP APIs. They could be other APIs. Doesn't matter. They could just be going on like a Unix socket. But there's an API. That thing stays stable. Then each of the services can move as fast as they want around that API. Occasionally you'll have to break that. Occasionally, you realize that API doesn't have the capabilities. That's why you version it. You create a new version of the API. The service that's consuming that API is still using the old version. Once that new version of the API is out there, then it can switch over on its own schedule to using the new version of the API. I skipped over number 7. Again, this is a team thing. I found that teams work best when they're either all co-located or all remote. Colocation can be a fabulous thing if it works for your company. You get the sort of water cooler conversations. It's easy to drop by somebody's desk if you need some question answered. But for a lot of folks that's not practical. In which case you're in remote mode. Everybody's remote. That means every meeting has a video conference or a conference call that they can be on. That means you over-index on writing things down so that if somebody's in a different time zone and there was a meeting they missed, they can just read what happened. And essentially, if you have a hybrid team where you have like half the people in one location and half the people remote, you basically just need to act like everybody's remote, and then it works pretty well. But I think this is one of the really interesting kind of challenges in terms of like productivity software, like how do you get remote teams working better together? And I'd love to see some cool innovation there, because right now it's basically the state of the art that I've seen is you have a shared Google Doc on a meeting, so everybody can see that doc. You have a video conference, and it's pretty good. Not quite the same as everybody being in the same room, but it's still pretty good. Okay, we already did this one. All right. What is this one? Oh, yeah. Okay, so you started off with a monolith. You scaled. Your product's getting traction. You started splitting into separate microservices with separate teams. Now you've got a new problem. This is a problem that we totally had at Heroku that we did wrong. Is you'll have teams that might be really, really productive, and they're all moving in different directions. It's like they're all running in totally different ways. And so that's not really good either. So you really have to over-index on your cohesive strategy. There's a lot of different ways to do this. I'm a big believer, if you can do it, in having first principles. Elon Musk is a big fan of this first principle thing. Like, what does that mean? Like, I heard this really cool quote from a friend of a friend. He was talking to somebody who worked at SpaceX. And somebody said, "What do you do at SpaceX?" The way he answered it is, colonizing Mars is essential to humanity's future existence. In order to do that, we need to build a spaceship powerful enough and economical enough to get us there. And in order to do that, we need to have engines that have a thrust of this. And so I work on the exhaust valve of the engines in order to make that happen. So there's that first principle of we need to colonize Mars, and that lets that engineer figure out like how to build that exhaust valve to solve the problems that actually matter. Another way to do it is, kind of what you need when you have a bunch of different teams is essentially just like some central strategy czar. You typically a head of product or a co-founder or a CEO that just continually says, we're doing this, and making sure people align to it. You want to have, I think when you have separate teams, you want to have at least, half to 70% of their time working on projects that are for the whole organization, but still give them maybe like 20% time to kind of work on their own projects, whether that's technical debt reduction or just some features that they think would be important because they might have some ground truth from their interactions with the market or their software development that they realize something's important. That's not important to the whole org, but it's important to their part of it. So give those separate teams like their 20% or 40% time to work on separate independent projects as well. All right. It's like they say in politics, it's the economy, stupid. I think in organizations, it's the culture. It's sort of trite, but it's really true. You want to create a place that people enjoy working at. They enjoy hanging out with their colleagues. That'll get you through a lot. Confession, I went to business school, and you do a lot of case studies in business school. And one of my meta takeaways, when you read, all the case studies are always about successful companies. And like almost every successful company in one of these case studies, there's always some really interesting, unique factor in their culture. And that kind of is it's kind of like another way of having that strategy that helps different teams figure out what they need to do. All right. And last but not least, use serverless, right? There's a talk about serverless, so I couldn't have left this out, but it really is true. And that's what I'm going to talk about next. I think serverless, and by serverless, I don't mean just functions. I mean, platforms as a service, app-based serverless things, container-based serverless things like Cloud Run that we launched. But serverless really, really, really can be a giant productivity boost. You are eliminating so much of the stuff that you would normally have to do in running software. It's not for everything, but for a lot of software, it is really great. And so that brings us to the next section. So why serverless and why App Engine? All right. So this is obviously I'm doing a lot of creative borrowing on my deck here. If you've ever seen Maslow's hierarchy of needs, this is like the sort of hierarchy of computing. At the lowest level, you have like the on-prem, you're running your own data center world. I actually, even before PayPal, I started off in this world. I was doing a startup and I rented a rack in a data center and I went down and I racked these physical servers and then I installed Oracle on them and it felt really, really cool. I was dealing with this heavy metal, but it's a lot of work actually. You have to deal with physical security, network hardware, physical servers, them going down, the internet connectivity, even if you're just like renting out a data center, and not most of that stuff isn't differentiated. Like if you're differentiating on how you rack servers, maybe you are. I mean, if you're like building like some crazy infrastructure, that is a place to differentiate. I mean, I think that's really where the cloud providers differentiate is how they operate that layer, or even Google outside of the cloud. Google's done a lot of cool special things in building these really amazing data centers that let us operate at global scale. So you can innovate it there, but most companies don't. So the next layer up is cloud. And cloud is really just where you take all the physical stuff out, but you really do the same things. You have virtual machines, you have virtual networks, you deal with cluster management, you still deal with OS updates. Again, like how many people do you feel that your companies are differentiating based on how well you update the operating systems on your virtual machines? Maybe, but I don't know, I doubt it. So next level up is serverless, and that's where you get rid of all this other stuff. You just focus on application development. In an ideal world, it would be just application development here. You just write the code for your app. In reality, you have to still monitor the performance. You're going to run into some scaling issues eventually and need to do some re-architecture. So you need to kind of keep track of that. But really, you're just focusing on developing your software, your code, your business logic. That's where I think 90% of companies differentiate these days. And then Maslow's hierarchy of needs. Once you've met all the needs, like eating and sleeping and all those other things, you have self-actualization. And so I think that's if you do all these things, you can self-actualize and actually build great products, which is hopefully what we all want to do. And I think as you go up this stack, obviously you get more productivity. The less other stuff you have to do, the more you focus on the stuff that matters. All right, so that's why serverless. All right, now we're going to kind of shift into the other part of the talk. I kind of mentioned that there's kind of two talks in one here, which is what's new in App Engine. How many folks are current App Engine users? Have you guys tried out the second-gen runtimes? Anyone? Okay, so this is the big thing that's new. We've been releasing what we've been calling the second-generation App Engine runtimes since. If I stand out of the light, can you guys still see me? It's like really blaring over there. Yeah, good. So we released what we've called second-generation runtimes, and I wish I had all this on a slide, but I'm just going to talk through it a little bit. App Engine of 10 years ago was it actually, for those who don't know, it predated Google Cloud. Yeah. Yes. Question? Thumbs up. It's good. Yeah. It is good. Yeah. It predated Google Cloud. The reason it's not called Google Cloud App Engine is because there was no Google Cloud when App Engine existed. It's actually, I think it's one of the only products in Google Cloud that is usually referred to as Google X. It's Google App Engine is the common moniker for it. Almost everything else is Cloud Spanner, Cloud Memory Store, Cloud Compute Engine. So yeah, and it was this all-in-one product. Because there was no rest of the cloud, you got everything all together. You had data store for storing your data. You had Memcache G, which was a Google proprietary variant of Memcache. You had a search API. You had a users API for managing your users. Is there anyone using the users API? Yeah. It's great. It's great, but I mean, if you were building an app today, so for those of you who don't know, the users API, literally, you can use an API that will manage your user data. So you don't need to have like a users table in your app, right? But you would never build an app that way if you're building it from scratch. You would just have a users table. There's a ton of libraries in every language that help you manage users, and that's how you do it. That was what was built. So there were a bunch of other restrictions. Because, and this isn't widely publicized, but because it sort of predated Google Cloud, Google App Engine was and still does, it runs in the same Borg cluster as the rest of Google proper. It's running right alongside of search and ads and all those other products that make the real money for Google. And so those App Engine, as a result, was super locked down. You didn't even have direct network access. You could not just call out to a network address. So you had to use this API called URL fetch. And you'd call the URL fetch API, and then some other service would go fetch what you were looking for. So it's just kind of a very funky environment. So what we've done on the second generation runtimes that we started releasing last year is we've basically defunked it. We took out those proprietary APIs. There's no users API. You just do the users yourself. You have direct network access. So most API client libraries will work for you. And the first language on those on the second gen runtimes was Node. It's actually been getting great uptake. Node was not available on App Engine Standard prior to that. Now we have all these languages. A couple of these were out before. A lot of them we just announced at the conference. So Google Cloud has 7 languages that we support. We now have 6 out of the 7 on the second generation runtimes. A couple of these are alpha. It's really easy. If you want to get into the alpha, you can just ping me. We basically let everybody in, even though it's officially a private alpha. You've heard about Cloud Run. That was the big serverless announcement at the conference. These App Engine second generation runtimes are running on the same infrastructure as Cloud Run. They're running actually in Docker containers, and Cloud Run is from a simplified point of view, it's just removing the sort of App Engine code building layer and exposing the containers directly to you. So I've got all these now. These are modern languages. You should try them out. You heard it here first. We are on those second generation runtimes. We are doubling the memory that you get. Right now, the smallest instance class, you get 128 megs of RAM. That hasn't changed in a while. And what we're seeing is actually that most apps, even really simple ones, don't fit in 128 megs anymore. So all the second generation runtimes are going to get double the RAM. We'll be shipping that this quarter. I'm crossing my fingers that it's going to happen in the next 6 weeks, but officially, sometime this quarter, there'll be no price change. You'll get double the memory on second generation runtimes. So surprise, it's going to be really fun. Like I said before, and this is really, really important, the second generation runtimes enable open network access. Why is that important? Well, Google Cloud's got some cool stuff. There's cloud storage for storing your blobs. That wasn't available on the old App Engine. It's available on the new one. There's Cloud Spanner, where you can build you can have a database that's like on multiple continents. On the last session, I demoed an app that was running on multiple continents using Spanner. But without open network access, you couldn't actually use any of those APIs. So now with open network access, you can just use the Google Cloud Client library and access those Google APIs directly. But like I said, and this is where sort of the product's a little complicated, because App Engine is still running in that main Google Borg cluster, it actually is not on the same network as the virtual machines that you might spin up in Google Cloud proper. And a lot of the products in Google Cloud, like notably Cloud Memory Store, are based on the virtual machines. So besides network access, the other really, really big thing that we announced here is VPC Connect. So Google Cloud has VPCs. I'm not a networking guy. Network to me is like magic pixie dust. But what's cool is it really is magic. It works. So this is a really cool town in France. The road to it gets underwater on very high tides. It's just like a little jewel box right down. So this is sort of App Engine before VPC Connect. It was just this little island. Really great if you had what you want on the island. But with VPC Connect, we've got a bridge from the island to the mainland. Kind of a cute little analogy. But the important thing here is you can have your VMs in Google Cloud. You can have the number one feature that's been asked for on the second gen runtimes has been a caching service, Memcache or Redis. So you can spin up your Redis instance, and later on, when it's available, a Memcache instance. It's in a VPC. You create a VPC connector, an App Engine, and you just address it on its internal 10.0. Whatever address, and it works. And actually, that was so far the folks who've been using the second gen runtimes. That's been the number one requested feature is just having a cache, and this delivers that.